Hello friends. So, we have been discussing about the anaerobic degradation this week, and in this particular lecture we will talk about the various characteristic, what are the various factors that affect the anaerobic degradation, the characteristic of anaerobic degradation steps and processes, and some of its application. Okay. To begin with, there are various factors that affect anaerobic degradation. The time, which is one of the important factors. So, as we were discussing earlier also, the acclimatization of the microbes with the substrate present in the system may take significant amount of time. At times even it takes in fact more than 2-3 months as well, but generally it may likely to take 3 to 8 weeks. If we start with the acclimatized group of microorganisms to begin with, we can reduce this time. Okay. So, that is again advantage to starting with acclimatized sludge or acclimatized bacteria, which show greater stability towards the stress which come at the startup phase, particularly like in the form of hydraulic loads, in the form of fluctuations in temperature, the level of various volatile acids, the pH changes, the ammonia concentration, those kind of thing. Then there is effect of pH as well, in the form of like the optimum pH range for methanogens is 6.6 to 7.6, and non-methanogens like hydrolytic bacteria and acidogens is 5 to 8.5. So, methanogens has more narrow range and more susceptible to pH and alkalinity changes. What happens that pH decreases in the reactor due to formation of short chain fatty acid compounds by acidogens. Acidogens have relatively higher range of working pH, so they can work at pH 5. Now, what happens that if acidogens are action and they are producing lot of acid, so what happens that pH may fall and the methanogens may get inhibited in that sense. So, there is requirement of buffering agent in the form of whether sodium bicarbonate or calcium carbonate that can be added regularly, and so that we can maintain the pH at desired level, because if we go too low in the pH, the acidogenesis may get greatly affected. Then of course there is the effect of temperature. So, anaerobic process mostly operate well at the mesophilic range, that is the optimum range 30 to 40 degrees, the best temperature range kind of for the anaerobic processes. Okay. The methanogenesis can occur at temperatures even at low as 12 to 15 degrees Celsius, but for more this thing it is more effective if the temperature is maintained in the good mesophilic range that way. The other things that affect actually are the nutrients. So, how many like the what is the level of nutrients? The optimum nitrogen to phosphorus ratio is 7. The minimum COD to nitrogen ratio is 350 to 7. Okay. So, that way 350 to 7 is to 1 is the kind of ratio which should be maintained. The COD to nitrogen ratio of 400 to 7 is considered optimum for high load, means the anaerobic process which are high rate. Okay. So, that operated in and the range of say 0.8 to 1.2 kg COD per kg VSS per day. There are various trace metals like molybdenum, selenium, tungsten, nickel is also necessary to sustain the enzymatic activities in the system. So, that is the effect of nutrient. A higher level of nutrient present in the system will not get removed because nutrient uptake is very low. So, there is some requirement of nutrient which is fairly low as opposed to the aerobic system, but if there are more nutrients are present, we actually it cannot take up all the nutrients. So, the removal of nutrient will not be there, but the advantage is that because requirement is low. So, if there is need to be added nutrient, we will have to add very little nutrient. Then there could be inhibition because of various things. The volatile fatty acids can lead to inhibition. So, due to the slow growth of selectiveness of the methanogens, they are often unable to convert short chain fatty acid into the methane. Okay, and that results in the accumulation of these organic acids. Again, as we are discussing, the accumulation of these organic acid may reduce the pH. So, this can actually decrease the further performance of the reactor. The VFA concentrations in reactor should ideally be maintained below 500 milligram per liter at any point of time, and preferably below 200 milligram per liter or that range. So, the among various volatile fatty acids, the acetic acid is considered to be the least toxic. It is not too too much of it is not highly toxic, and it can easily convert it to the methane also relatively, whereas propionic acid accumulation has been reported to be responsible for the failure of various anaerobic systems and anaerobic reactors. There is inhibition from the ammonia or nitrogen. So, high ammonia concentrations generally causes rapid production of the volatile fatty acids, again which leads to the decrease in pH and reduce the methanogenic activity. There is inhibition from the sulphide concentrations. So, oxides of sulphur get reduced to the sulphides, and sulphur containing amino acids may undergo degradation from the sulphide with the help of sulphur bacteria. Okay. So, that again hampers, there is a competition between the sulphate reducing bacteria and methanogens for that purpose, and there is a possibility of heavy metal inhibition. So, various heavy metals like copper, nickel, lead, chromium, etc., if they are present in significant concentrations, if they are present in a little higher concentration, they may induce toxicity to anaerobic reactor. So, these are the susceptible points for the anaerobic reactor which actually affects and controls the performance of anaerobic digesters or anaerobic systems. Now, if we see the characteristic of these processes, so the lower as the biomass yield is lower as compared to the aerobic processes. Okay. So, because of slow metabolism of microorganisms. So, microorganisms, in the absence of oxygen, the metabolic rate of the microorganisms is slow, and as a result the conversion of the substrate to the cell mass is very low, and that results lower biomass yield roughly of the order of 5% as opposed to the aerobic process, which is 40 to 50% or even higher at times. Then fewer nutrient requirement, as we were discussing, that because the biomass produced is less, the less biomass is being produced. So, obviously there will be lesser requirement of the nutrients. Okay. So, for wastewater, where there is not sufficient amount of nutrient present in the wastewater and the extra nutrient is to be added. So, the cost of nutrient addition is much less for anaerobic process as opposed to aerobic process, because the requirement of nutrient for in aerobic system is far higher as opposed to the anaerobic systems. But at the same time, if there is already nutrient present in the system, so aerobic process can remove some of the nutrient because they assimilate them into the cell mass, but in an anaerobic system the nutrient removal is not too much because of the less biomass produced at the first place. Then there are higher volumetric loading. Okay. So, anaerobic processes generally have higher volumetric organic loads than aerobic process. So, that is in a terms advantageous, because the smaller reactor volume and installed in a lesser space may be required for treatment. It can handle the good loads. So, organic loading rate generally 3.2 to 32 kg COD per meter cube per day is used for anaerobic processes, whereas just 0.5 to 3.2 kg COD per meter cube per day is used for the aerobic processes. Now, if we look at the operational conditions, so we talk about various positive aspects, there are negative aspects as well in terms of operational conditions. So, the major concerns with the anaerobic processes are their longer startup period. As we discussed, it may actually go for months. Okay. For anaerobic process as opposed to the few days in the aerobic processes. There is sensitivity to the possible toxic compounds, there is operational stability issues are there, there could be potential of odor problems, and there, because it is generating CO2 and methane, so these gases could be corrosive, so there could be impact on those as well. And there is a need for alkalinity addition in order to control the pH. So, 2000 to 3000 milligram per liter calcium carbonate needs to be kind of maintained for an acceptable pH with the high gas phase CO2 concentrations. And another thing, as we discussed earlier as well, that there might be need for the further treatment, because effluent which is coming out of this thing may not have considerable removal of the pollutant. It could be considerable removal, but it may not actually bring it down to the desired level. So, if let us say your COD limit is 30, and if you are starting with a waste which is having a influent COD of 2000 milligram per liter, so it may bring 2000 to say like down to 300, 400, 200 in that range, but it may not bring it down to 30. Okay. So, that why there might be requirement of further treatment in case of the anaerobic treatment processes if it is not meeting the desired criteria. So, even after these limitations, and as we discussed in the earlier week, that number of installations of anaerobic reactors are increasing kind of exponentially. So, we discuss what makes it attractive as well. So, if we look at the application in the sectors in which this anaerobic treatment could be used. So, anaerobic processes is usually used for the treatment of significantly concentrated wastewater. Okay. And why it is done? There are several reasons. The first and foremost thing is that because the biomass growth is very low, 5%. So, if you are starting with a low substrate concentration, the biomass growth is going to be even low. So, almost no biomass growth. Okay. And if you do not have biomass growing in the system, and there might be, like, if we come up with a very good, pretty good system, it may work, but there might be possibility of biomass washout from the system. So, what happens that this is one of the very common problem when the USB is applied to the domestic sewage, that because of the low concentration of the substrate or low concentration of COD, the amount of biomass produced is not significant, and rather what we see that there is biomass washout takes place, because these when with low COD, the biomass which is, even though the biomass which is produced is not of good quality or is not of high density. So, the retention of this biomass is difficult, and as a result we may see that biomass getting washed out with the effluent. So, we end up losing biomass instead of producing biomass, and that becomes a problem, because if the reactor cannot sustain significant or sufficient amount of biomass, it cannot actually give you the good treatment. Okay. So, that is one problem, and further with the low amount of influent COD, the potential of generating methane is also very low, and if you go on trapping that methane or putting a purification system, so that makes it a very costly process. And the collection of methane, even though methane is being produced, even though methane is being generated, but the collection of methane at first place becomes a very challenging task in terms of like the financial sustainability. Whether it may or may not be financially sustainable, it has to be seen. So, those are certain issues, the kind of biomass washout, the low biomass production, the not feasible collection of methane, and then if you allow methane to go away, so it has far more higher greenhouse gas potential as opposed to the carbon dioxide, and can actually be add to global warming and those kind of thing. That is the reason that anaerobic processes may not be considered apt for municipal wastewater with lower concentrations of biodegradable COD. It's not as such that it cannot be used. There are anaerobic processes or anaerobic reactors working for the treatment of sewage as well, but if you see the number wise, it is the aerobic system which kind of dominate grossly, and they are generally, aerobic systems are generally preferred over anaerobic system for the treatment of municipal sewage, because of the low concentration of biodegradable COD, lower temperature and high effluent quality needs. So, and again you may need nutrient removal as well, which is not possible in the anaerobic system. But for industrial wastewaters, if we see, the industrial wastewater generally have a significantly high amount of biomass, significantly high amount of substrate concentration. So, then with much higher biodegradable COD concentrations, it becomes very good to go for anaerobic system. Okay. Their temperature might also be elevated, the volume is less. So, that way we can go for a high rate anaerobic treatment process, and we can get, even if we do not treat it to the desired level, even if your anaerobic system is not treating it to the fullest, to the sufficient level. A partial treatment is also welcome because it is not taking too much of energy. If you go into the aerobic system, the energy requirement would be quite high. Okay. So, that is why. So, anaerobic processes are generally considered much more economical for industrial wastewater, and even if these are not resulting in the effluent having higher COD concentration than desired, then also it is advantageous to use anaerobic system as a first stage of treatment or as a pre-treatment, and which could then be followed by the second stage of the aerobic or advanced treatment steps to get the desired quality of effluent. Because let us say you are starting with a COD of 10,000 milligram per liter, okay, and your anaerobic system is just giving you say 60% removal. So, it is bringing this 10,000 down to say 4,000 milligram per liter, and then you are going for let us say aerobic process or oxidation process. So, your oxygen requirement now or the requirement of aeration would correspond to just 4,000 substrate concentration, but if you directly use this thing, your oxygen requirement is too high because that will correspond to 10,000 milligram per liter substrate requirement. So, the amount of oxygen or amount of aeration you save here is worth adding a anaerobic step over here in terms of this thing, because you are not providing any energy to this one and you are getting removal of 6,000 milligram per liter even at very moderate efficiency without too much of investment. And rather this if let us say of this 6,000 milligram per liter, significant part can be converted in the form of gas, so in the form of biogas. So, it may actually end up sort of generating energy or making this process self sustainable, and that is why it is advisable even at lower effluent, even if the effluent concentration or the outlet in the effluent which is being produced is not meeting the criteria, then also we can use at a first stage of treatment. Okay, and that is how it is being used in the industry. So, many of industries are using USB to begin with or an anaerobic process to begin with, and then go on to the aerobic or advanced process for producing effluent of the desired quality. Okay. But again, that way also this is always helpful to work in that range. Now, if we see the various types of industries whose effluent can be treated using anaerobic processes, so there are like slaughterhouse and cold storage. So, all such effluents which have relatively less recalcitrant compound and more of the biodegradable organic matter. So, very high COD with biodegradable products like alcohol production. Okay. So, there is lot of in the alcohol production industry release lot of COD 20,000, 30,000, 40,000, even at times higher than that. Okay. And that can actually be degraded or decomposed pretty nicely even if with the significant. Then breweries industry may have COD in or leather factories may have dairies, sugar refineries, these may have COD at times in the lakhs. Okay. So, refineries can actually come up with a COD of say 2 lakh. Now, imagine the kind of aeration requirement would be there if you want to degrade 2 lakh COD with activated sludge process. Okay. So, that is going to be a huge costly intensive process, and if with that thing even anaerobic system which is 60%, 70% efficient can remove 70,000 of COD without much of the cost, it is always a welcome step. So, that is how these are used in this. Then starch production, yeast production, soft drink production, wine production. So, these are all the industries which leads to the effluent with high COD value: potato processing, coffee processing, fruit processing, fish processing, vegetable processing. So, these are the variety of industries which actually can be kind of, we can go for using anaerobic processes as maybe first step, or there are many times that multi-stage anaerobic treatment is also provided. So, you just provide us anaerobic treatment and then let us say with 60% efficiency. So, if your influent COD is say 1 lakh, with 60% efficiency you reduce down to 40,000, provide another anaerobic system which can bring that 40,000 to say let us further bring down to say 10,000 or 8,000, 6,000, and then one can go for the other processes. So, a sequential step can also be chosen. Now, if we see the various reactor systems in the anaerobic this thing, so there are low rate reactors and there are high rate reactors. These low rate reactors, there are like primarily work good for wet digestion or dry digestion. So, for mostly suited for the digestion of solids. Okay, when you have low solid content less than 20%, you can go for wet digestion. When you have high solid concentration, we can go for dry digestion, but these are for solid. We are more interested in this zone which is high rate anaerobic processes, which is good for the wastewater, where the solids, typically total solids, are 4 to 10% only. Okay. So, with biomass retention, the hydraulic retention time is far less than sludge retention time. Okay, because in low rate process no biomass is retained. So, the time, the amount water or the amount your material spends in the reactor, same is the amount of sludge, then it is discarded, whereas in high rate processes the hydraulic retention time is much less than the solid retention time or sludge retention time. So, the sludge which is produced is retained into the system, and the water has much lower retention time. So, that is why these processes are high rate, these works well, and there are quite a few high rate processes. There are anaerobic contact processes, anaerobic filters, there are USB reactors which is called as upflow anaerobic sludge blanket, there are fluidized bed reactors, and then there are hybrid reactors, means we can have a hybrid of say USB and anaerobic filter, or USB and anaerobic contact process, that kind of thing. Then there is sequencing batch reactor, anaerobic sequencing batch reactor, which is known as ASBR, and few more other configurations are coming in the industry. So, that way the different configurations are being used, okay, in such system. So, these are some of the basic like reactor types. If you see the classification of these reactors, so there are conventional systems which are like sludge digesters, septic tanks, or anaerobic pond, which has been used since ages, and there are high rate systems for wastewater purpose. So, these high rate systems are with dispersed growth or with attached growth. So, in attached growth we can have fixed bed reactors or rotating bed reactors or fluidized bed and expanded bed reactors, and then in the dispersed growth again we can have two stage reactor or a flow anaerobic sludge blanket kind of buffled reactors. We can have expanded granular bed reactor, okay, which is kind of a fluidized system, okay, which keeps in the suspension, and then there is a possibility of reactor with internal circulation. Okay. So, we can recycle some of these things. So, like this is an example of fluidized bed reactor. The systems can also be classified based on whether they are dispersed growth or attached growth system. So, dispersed growth system, as we discussed this, and attached growth system will have fixed bed, rotating bed, or expanded bed system, and there is a quite a few classification of the dispersed growth system. So, these are some of the common configuration, and we will take up a few in the next class. We will start with flow anaerobic sludge blanket, and then as the time permits we will take few other configuration if possible. So, see you in the next class. Thank you.